Hi, welcome to CEE 117, or Statics of Rigid Bodies. Today, we are going to discuss about trusses. So in this section, we will apply the key concepts of equilibrium in common structures starting with plane trusses. Trusses are important structural systems as it supports many types of loads and is commonly used in modern engineering structures. Calculating the member forces of a truss is one of the most important steps to determine the proper design of its members. So first of all, what do we mean by trusses, or what are trusses? So a truss is a commonly used structures composed of slender bars joined together to form a pattern of triangles. So trusses are commonly used to support loads transmitted from roofs, bridges, and many more. So this is an example of a truss supporting our roofing materials. So, what you've been seeing in your homes na parang triangle-triangle ang form. So, we call that truss. Okay? This is the truss. So, kahit na isang triangle lang yan, truss pa din yan. Okay? Truss pa din yan. So, what are the uses of truss? For example, we use that to support roofing loads, or we call them roof truss. Pwede din sa mga bridges, pang-support sa mga bridges. So we call this bridge truss. Okay. So to design the members of a truss and its connections, it is important to remember the assumptions to make the process more simplified. So when we do analysis on trusses, these are following considerations or assumptions. So first, the weights of the members are negligible. So look at this one, diba? The truss is made of very slender materials. So, when we do analysis on them, we consider na wala silang weight or negligible ang weight. Meaning, it's too small to even consider. Okay? And then, all joints are considered as smooth pins. Okay, so lahat ng mga joints ay pins daw yan siya. So, in reality, di ba, dili man jud inana yung makit-ana, inana lang na mga dot-dot dara. But actually, in reality, naka-weld ng mga members. So, gina-consider nato ni na at the common point where the line of action of the members meet, it forms or is called a joint. Ito. This is called a joint or smooth pins. And then the third consideration, the applied forces act at joints. So, ito, for example, di ba, nakita natin na ang roofing truss, sinusuportahan niya yung roofing materials. So, you would probably think na dito yung mga loads, diba, na-apply. So, in our manual solving for trusses, hindi dira naga-act yung mga force, but rather on the joints itself. Sa joints talaga. Okay, so that would be our assumption here. Yun, tingnan nyo, sa joints siya nag-act, yung mga forces. Okay? So, ito lang ang tandaan pag mag-analyze ng truss. Again, first, the weights are negligible. The weights of the members are negligible. Next, all joints are considered as smooth pins. And lastly, the forces are applied at the joints. Alright, so using the given assumptions, the FBD for any member of a truss will contain only two forces, which is exerted on the member by the pin at each end. So therefore, each member of a truss is a two-force body. So, two-force body ang bawat member ng truss. So, when dealing with the internal force in a two-force body, the internal force of a truss member might either be tension or compression. So, dalawa lang yan. Okay? Pwede tension ang force ng member or compression. Gina-compress ang member. Okay, so by the way, why is it important that we have to identify which members are tension or which members are compression? For example, this one is an example of a truss. So, why is it important na sabihin natin, oy, dito tension yan, compression yan dito, tension yan, compression yan dito. Why? It's because when we do steel design later on, kasi ang ginagawa pa lang natin dito is we have to solve the forces acting on each member. But designing the truss is entirely different matter. Like, ikaw na talaga magpili kung anong size, anong fabrication ang gamitin natin for a specific truss. For example, sabihin natin, uy, gawa ka nga ng truss para dito sa bahay ko. Okay, so ang first mong gagawin, magmamodel ka muna ng truss mo, kung anong form ng truss ang gusto mo, kasi maraming klase-klaseng truss, depende sa pattern of triangles. And then next mong gawin is ito, isolve mo force kada member. Okay, isolve mo anong force nito, anong force nito, ang force nito, lahat yan, lahat ng members. Okay? And then, pag nagawa mo na, i-identify mo which one is tension or which one is compression. Kasi, pag design mo later on, iba-iba man yung process pag tension members and then iba din yung process pag compression members. So, dapat nakasegregate na. Kinsa dira ang tension, kinsa dira ang compression. And then, pag okay na, then magpili ka na ng mga sizes na pupwede sa iyong design. Okay? So, ngayon, since we are still at the beginning stage pa sa tuang curriculum, so i-introduce muna ano yung mga trusses at kung paano mag-solve ng forces kada member ng trusses. And then, how to identify which one is tension or which one is compression. Okay? So there are two ways in which we can solve trusses. We have methods of joints as well as methods of sections, of which we are going to discuss later on. So let's do methods of joint. So here is the illustration. Using the methods of joints, determine the forces in each member of the truss as shown. So here is our truss. So we have to identify or solve the forces in each member and then identify which one is tension or which one is compression. So ano pala yung tension or compression? So say for example, we have this joint here. So if ang force is away from that joint, so the force here is tension. Okay? But if the force is towards that joint, going to the joint, that would be compression. Okay? So, this one is tension, this one is tension, this one is tension. For compression, going to the joint. Compression. Okay, basta anything going towards the joint, compression ang force. Pag going away from the joint, tension. Okay, so always remember that one. Now, for us to solve the truss, the first step would be solve for the reaction. Okay? And then in order for us to do that, let's look for the supports. So the support at A is a hinge of which the present forces are vertical resistance as well as the horizontal resistance. And at E naman, that's a roller. So the forces that are present there or the force that is present there is only the normal at E or pwede natin sabihin EY kasi Y naman is the vertical axis of the truss. Okay, so how do we solve for the reactions? We apply the equilibrium equations. Which one? Okay, para mas madali, sum up moment either from A or E. So say, sabihin natin sa E. Equal to 0. This time, assume clockwise positive. So, AY, moment arm niya about E, 6 times 4, that's 24. And then, ang AX, wala siya moment about E because its line of action passes through E. So, ang meron lang is itong 8,000, which ang moment arm is 18. And then, ang 3,000 moment arm is 12. So, solve for AY. So, AY is 7,500 pounds. Since positive man ang answer, so tama ang assumption nato na pasaka siya. Okay, how about we solve for EY? So, for EY, sum up na lang din tayo ng moment about A. So, this time, say counterclockwise positive. So, EY times moment arm about A, that's 24, minus 8,000 times 6, minus 3,000 times 12. Okay, therefore, EY is 3,500 pounds. Since positive man ang lumabas, so tama ang assumption na pasaka. Okay. Now, let's do the checking kung tama ba ni na reaction. Otherwise, if mali, hindi tayo mag-proceed. So, dapat tama agad ang reaction. So, for checking, let's just do sum up forces vertical. Okay, assume na upward positive. So, AY plus EY, diba? They are both upward forces. Minus 8,000 minus 3,000 should be equal to 0. Okay, I believe they are equal to 0. Alright, so sino na ang wala pa? Si AX. Dapat malaman natin si AX. So, we can only do that by sum up what? Mas madali mag-sum up ng forces horizontal. This time, assume natin right forces positive. So, AX, wala nang ibang horizontal force. So, equal to 0 na yan. So, that should be it. Okay, so what's next to do is we now do the methods of joints. So, methods of joints is from joint to joint. So, every joint, ato agad siyang tanawon. So, this must be very kanang Tiring kasi if maraming joints ang iyong truss, so matagal ka din matapos kasi joint per joint man. In this case, pila man ang joints ani? 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 joints. Okay, so 8 pud ka mag-tanaw. Okay, but even though tiring siya, sure man pud siya na way na makuha nimo ang force per member. Alright, let's start at joint A. So we work our way from A to E. Pwede din E to A, bahala kayo, basta joint per joint. Okay? So, oftentimes, mas maganda mag-start tayo saan yung known reaction. So, since known naman ang reaction at A, at saka E, we can start from there. Hindi tayo mag-start sa B, C, D kasi baka marami pang unknown dyan. So, doon tayo mag-start sa known na ang reaction. So, A or E. Okay, so this time, let's start sa A. So, at joint A, tingnan ang mga members na nakakabit at A. So, ang nakakabit kang A, we have force B or AB, right? May horizontal tayo na force AH. And don't forget, may vertical reaction tayo na AY and then AX. Okay? So, sa joint, we have to apply the equilibrium equation kasi in every joint, they are assumed to be in equilibrium. So, dapat apply natin ang equilibrium equation. So, unahin natin sum of forces vertical. Assume upward is positive. So, AY plus vertical component ng AB. Don't forget, ang slope nito, 8, 6, 10. So, therefore, plus force AB times slope niya vertical is 8 over 10 equal to 0. Wala nang iba. So, AY, na-solve na 7.5 plus force AB times 8 over 10. So, we have force AB to be negative 9375. Okay, by the way guys, at joint A, inassume ko na pagputulin natin tong member, tension ang lalabas. Diba yung tension is away from the member? Diba? Away from the member or from the joint. So, ang force AB away from the joint, so inassume ko na tension, si force AH away from the joint, inassume ko na tension. But then, we found out na ang force AB pala is hindi. Kasi negative yung answer. So, hindi pala siya tension as compared to our assumption. So, sabihin natin dito, negative, 9375. Pero, lagay natin na compression. Okay, so this must be our final answer. Okay, next is we do sum up forces horizontal. This time, we assume right forces are positive. So, force AB, horizontal component niya is 6 over 10. Diba, pa-right man ang horizontal component ng AB. And then, AH po, pa-right man po ng AH. So, plus na siya sa itong equation. Diba? And then, meron pang AX equal to 0. So, na-solve naman ang force AB. So, ibutang na to unsay nigawa sa force AB sa tong pag-solve. So, negative 9375 kay compression man times 6 over 10 plus force AH plus AX na 0. Solve na 0. Okay, so we can have force AH to be negative 9375 times 0.6 plus X equal to 0. So force AH is 5625 pounds. So, positive ang lumabas. It means to say na tama yung assumption natin na tension si force AH. So, butang na lang nato tension. Okay, very good. Now, wala nang iba, di ba, na unknown at joint A, nakuha na si force AB at force AH. Now, let's move our way to joint B. So, at joint B, ano yung mga nakakabit at joint B? So, para mas madali, assume natin na tension lahat ng kumabit, meaning away from joint B. Okay, so ang kumabit at joint B, to force BC, to force BA, okay? And then, meron din tayong force BH. Tingnan ang joint B. Ito ang joint B, di ba? Ano yung kumabit? Force BA, force BH, force BC. Then, don't forget, meron ding 8,000 na load sa taas. So, if mayroong naglagay na force or load dyan, lagay nyo din. Okay, so those are the forces acting at joint B. Now, let's do the equilibrium equation. Okay, ilagay muna natin ang slope ng force BA. Ang slope niya is 8 vertical, 6 horizontal, 10 hypotenuse. Okay, so sum up forces. Okay, unahin natin vertical, equal to 0. Assume pasaka forces are positive. So, look at the vertical forces at joint B. So, ang mga vertical forces, negative ang 8,000 kay pababa. Negative pod ang vertical component ni force BA. Unsay ang vertical component? 8 over 10, di ba? Ug minus pod ng force BH. Anong iba? So, go na. Okay? Ang force BA, same lang na siya sa force EB. Parehara na sila. Yan, solve naman ng force BA o force AB na interchange lang ang letter but same value. So that would be negative 9375. Okay, butang jud ang negative ha, kung negative ang nigawas sa force AB or BA. Times 8 over 10 minus force BH. So, ma-solve na to ang force BH. So, the answer is negative 500. Or, more appropriately, pwede natin ilagay 500 pounds but compression. Okay, so that would be our final answer. Okay. Next is sum up naman tayo ng forces horizontal. Assume right forces are positive. So look at your figure. Which one is horizontal na pa-right? Positive siya. Force PC, pa-right man na siya. So positive. Minus, di ba, ang horizontal component sa force BA is pa-left. So minus siya. Times na to siyang slope na 6/10. So wala na, equal to 0. So force BC, again, force BA or force AB are the same. So negative 9375 times 6/10. Solve for force BC. Negative 5625. So it also means na 5625 but compression. Okay, so this must be our final answer. Okay, now we are done with joint B. So let's go to joint H. So at joint H, ano yung mga members na kumabit sa kanya? So ito 'di ba? This is joint H and then assume natin na tension yung mga members na kumabit sa kanya, meaning away from joint H. So this one is joint force HB, 'di ba? This one is force HC. This one is force HG. And then sa left is force HA. Okay, look at joint H. Diba? Ito yung mga kumabit sa kanya. HB, HC, HG, and HA. Yung connect sa joint H ba? Unsa na mga member? So, gidrawing nato and then gibutang pod nato na assume nato na tension. Anyway, pag solve natin later kung mo negative, meaning compression pala. Right? Don't forget to put the slope for HC kasi ano man na siya, inclined. H6, 10 gyapon hypotenuse. Okay, so let's do sum up forces vertical. So force HB plus force HC. Vertical component is 8/10. Wala nang iba. Equal to 0. Don't forget that force HB na solve na. Parera na sa BH, which is negative 500. Plus force unknown. Okay, and then solve for force HC. So, positive 625 means to say na tama na tension ang atuang assumption. So, na siya. Okay, next, let's do sum up forces horizontal na naman. Okay, let's look at the horizontal forces. Force HG plus force HC. Horizontal component is 6/10 minus force HA equal to 0. So, force HG plus ang force HC na-solve naman. So, 625 na siya times 6/10. And then, ang force HA na-solve na po na kanina. It's the same as force AH. 5625 na positive. Okay? So, solve for force HG. So, the answer is 5 to 50. Again, positive man ang bunga. So, tama na tension. Alright, let's do. Done na to sa joint H. Let's do joint C. Or joint G. Pwede sa joint G. Sige, joint G. At joint G, look at mga members na nikabit sa iyaha. So, copy ko na lang to. Para dali lang makita. Okay. At joint G, ano yung mga members na kumabit sa kanya? Ito, at saka ito. Okay, so assume na tension lahat, meaning away from the joint G. So this one, kanang vertical force GC, diba? And then force GF, and then force GH. Okay, so sum up forces vertical, upward forces positive. So, meron bang ibang past horizontal vertical force? Wala na, force GC lang. So, 0. So, ibig sabihin, force GC is just 0. Or what we call as zero force member. Meaning, wala siya force na gina-sustain. Kibali, kaning force GC or member GC, redundant na siya. Meaning sa redundant, nagdungag-dungag sa truss pero wala din siya ikatabang sa truss kay wala man siya force na gi-sustain. Kasi nga, zero force member siya. So, this is a redundant member. Murag, sobra lang siya. Gibot ka na, wala siya gamit na member. Kasi, zero force member siya. Okay? Now, let's move on to sum up forces horizontal. This time, assume right forces positive. So, force GF minus force GH, dalang iba, equal to 0. So, na-solve naman ang GH, diba? Or HG, pareha lang na siya. So, force GF is force GH is equal to 5 to 50 pounds. Tension. Okay, very good. Dali lang. Alright, we're done with joint G. Now, let's move on to anong after ng joint G? Joint C naman. Okay, so at joint C, ano yung mga forces na kumabit sa kanya? So, we have force CD, we have force CG, we have force CF, we have 4 CH, and then 4 CB. 1, 2, 3, 4, 5. 5 fours. And then don't forget, meron ding 3,000 pound at joint C. Okay, so look at the mga slopes. So ang slope ng CF, 6, 8, 10. And here also 6, 8, 10. Okay, so sum up tayo, forces, vertical, equal to 0. Assume pasaka is positive. Okay, so wala may pasaka no, so negative na tanan. Negative 3,000 minus 4CH. Vertical component is 8 over 10. Minus 4CG minus 4CF. Vertical component 8 over 10. Pat kabuo, equal to 0. Now, na-solve naman ng 4CG, diba? And 4HC. So, CH or HC, pareha lang na siya. 625. Ang 4CG or GC, na-solve na po na 0. So, unknown ang 4CF. Okay, solve for 4CF. Negative 4375. So, it means to say na compression pala ito. And then, sum up forces, horizontal. This time, assume right forces positive. So, ang mga horizontal lang dyan, horizontal component ng CF, 4CD, okay, minus 4CB, minus horizontal components of 4CH. Okay, wala na. So, ang 4CF na-solve naman. So, negative 4375 times 6 over 10. Ang 4CD wala pa. So, anon? Ang 4CB or BC, pareha lang nga sila. Na-solve na to be negative 5625. And then, ang CH or HC, na-solve na po 625. Okay, so we can solve now for 4CD. Oh, ang 4CD sa tong equation is plus kasi pa-right siya. 'Di ba? At joint C. So the answer would be negative 2625. So compression, so 2625 pounds na compression. Okay, alright. We're done now at joint C. Now let's move on to joint F. So ano yung kumabit at joint F? Look at joint F. So ito yung kumabit at joint F. Meron tayong force FD, so tension away from the joint. Force FC. And then we have force FE. And then we have force FG. Okay, always assume na tension. Anyway, tama lang man na siya later on para mas madali. FC, FD, FE, FG. Okay. Now let's do the equilibrium equation. Okay, sum of forces, vertical equal to 0. Say upward is positive. So, ang slope ng FC, by the way, 8 vertical, 6 horizontal, 10 hypotenuse. Okay, force FD plus force FC times 8 over 10 equal to 0. So, na-solve na ba ang force FC? Yes, that is 4CF. 4CF or FC, parehara na siya. So that is negative 4375 times 8 over 10 equals 0. So solve for FD. So positive 3,500. So tension kasi positive man. Okay, now let's go to sum up forces, horizontal. Say right forces positive. Force FE minus force FC. Horizontal component 6 over 10 minus force Fg equal to 0. So solve for force FE. Ang force FC, pareha lang na siya sa CF. Okay, negative 4375. Ang force FG, kaya na-solve na, that was force GF, diba? Force GF is 5 to 50. FG or GF, pareha lang na sila. So, positive 2625. So, tension. Okay. So, let's go to at joint D. Second to the last na siya, na joint. Okay, again, assume na tension are away from the joint tanan force. Okay, ang slope sa force DE kay 8, 6, 10. Okay, sum up forces horizontal equal to 0. So force DE 6 over 10 minus force DC. And then ang ang DC kaya na-solve naman siya. So we can get that one. Force DC or CT nasa joint C. Negative 2625. So the answer is negative 4375. Or 4375 na compression. There you go. Okay, so di na ta mag-sum up forces vertical kay nakuha naman nato ang force DF or FD. Okay, sa last joint, mo ni atong checking. Dapat tama. Okay, so sa last joint, 'di ba, at E man na. So unsa may ni connect at E, kana o kana, ug napoy normal at E or EY. So ang nato diri, this is force ED, force EF, ug EY. So, ang slope sa ED kay 6, 8, 10. Okay, so sum up forces vertical muna. Assume pasaka positive. So, EY plus force ED times 8 over 10 equal to 0. EY is 3.5. So, solve for ED ha. Dapat tama sa ato ang na-solve na kanina. So, force ED or DE is the same na negative 4375. So, tama ang atoang mga values. Okay, so that's one way of checking. Dapat pareha na sila. Pareha mo na sila na member.